Today, let us talk about your project number 2. To discuss about your project number 2, I need to refresh your memories for the two-dimensional array. So for a multi-dimensional array, it's an array that is accessed by more than one index. For the simplest example of a two-dimensional array, is going to be things like this. Define the data type, give the name of the array, and then specify 2 indexes. The first index will give you the what we call the row of the index. The second index is giving you the columns of the index. So this gives us a 3 by 3 two-dimensional array. To access the two-dimensional array is actually very straightforward. This is a simple example. If you have not done two-dimensional array for a while, I would recommend you to write a simple two-dimensional array to refresh your memories. So in this case, you can see that we have defining a number of I equal to 3, number of j equal to 3, and then we simply define the same two-dimensional array we see in our previous slide. In that fashion, we will be able to access each box, each location by providing the first index as well as the second index, and this way we will be able to retrieve the spaces that we have been created. That is the refresh of the memories for your two-dimensional array. So now let us talk about your project. So for your project, I want you to use multi-dimensional array or two-dimensional array to simulate linked list implementation for the stack. That sounds a little bit complicated, okay? So basically, I want you to simulate linked list implementation for the stack. The only catch is that I don't really want you to use pointers because you should know how to use pointers already. What we really want to do is we use two-dimensional array to simulate the whole process. So let's take a look of how is this possible. The summary is node in a linked list contains 2 parts. You know that. A data part, and the data part is the one that stores the element or the value. The next part is going to indicating where's the next location going to be. So this suggests that each node can be represented as a struct that has linked list can be representing an array of the structs. You are asked to use a two-dimensional array to simulate the linked list and use it to construct the whole process in the 6 basic functions, including construction, empty, push, top, pop, and display. This project's objective is enhance your ability to manipulate two-dimensional array or multi-dimensional array. Familiar with the idea of the linked list, so you need to have the whole idea of the linked list and then move from that to the next level. Enable yourself to perform 6 basic functions of the stack by simulating the linked list. The due date will be specified on the blackboard. Again, this is going to be an individual project, so please work on your own. Don't do something stupid. So here is the definition for the whole project. First of all, before you even started, of course, you need to familiar yourself with the two-dimensional array concepts already. I also want you to do something special. I want you to search online to find out how to include the random library in C++ so that you can really call a random function. You may have not learned how to do a random function, but I can guarantee you, go to Google, search for random function in C++. You can find a lot of information. And that is going to be as simple as call the library of the vector and then use the function. I want you guys to have a capability of search online, find something that you need. And trust me, it's not complicated at all. So just include the right library, call the right function. You would be able to create some random functions, random values already. So once you are able to do that, you have all the preparation works done. I want you to start doing this. Write the construction of 5 basic functions for the stack list below by using a two-dimensional array. So what you need to do first of all for the construction, you simply create a two-dimensional array as simple as like int, give the name array with 2 indexes. The index is going to be 26 and 2, so that you would be able to create a 2-dimensional space similarly to this one. So you can see that if you create an index of 26, then you will have index from 0 to 25, and then the second index would be 2, so that you can have the value. The first one, which is the 0 index of the second index, is going to be indicating the element part, and the second one is going to be your next part. So you will be able to create a 2-dimensional space like this. You will also want to initiate a top variable, which can be integer, equal to null, which is like -1, indicating that it's the current top of the function. So that is basically your construction. Now, once you have that preparation, first one is super easy because you know if top equal to -1, that is an empty situation. Push is the one, and as well as the pop are the 2 major functions that you need to have some major changes. So starting with the push. What push operation is, add a value at the top of the stack, so that's still the same, in a valid random space. So you are actually playing the operating system. First of all, you need to use the random function I want you to look for, generate a random location. When that random location is generated, obviously that random location need to be from 0 to 25. So you need to not only generate a random value, you need to make sure that value is lying in the range of from 0 to 25. So a mod operator is going to be your best friend. Say that you have randomly choose a location. What you will need to do is that you use that random location. Okay, so in this example, suppose that your random value is going to be when you try to push a value, suppose the value is 5. Okay, so suppose value is 5. You also you need to randomly generate a location. So when that location is randomly saying that the location is 7, which is the random location that you generated, then you need to use that space. Okay, you see, you put 5 into the value part because that's the very first item. The next one need to be null, and the top will change to the location that you randomly generated. So you see that this is like the whole process of the linked list implementation, and you are playing the operating system to decide the location randomly. And of course, that random function also need to check to see if the randomly generated location is available. Okay, for example, if 7 is being used, then the next push function can choose all other locations but 7. However, because it's chosen by random function, so it's a possibility that you choose 7 again. When that happens, you need to make sure that's not going to use the location to override what's already there. So you see that to do the whole process, you of course need to be familiar with the push operation of the linked list implementation. So you can see that I want to go over this one a little bit more detail with you guys to help you finish this project. So you see that in the beginning, when we try to say push 5, and then the push function need to, first of all, the new node operation is finding a new location. So we actually, like we said, use a random function to randomly find a location. So in this example, 7 is the random location. We need to use a variable to remember that is the new location that we generated. So of course, you need to have whatever name that you want it to be, new space, new PTR equals to the random location that we generated. So you need to remember that location. Next is the time you put the value 5 into the data part. Okay. So to do that, you already know the element is 5 because that's the value you want to push in. How do we push into this location? So it's actually a 2-dimensional space problem. The whole array, so say called AA, called array. Then the first index to access here is going to be 7, which is the one that you just generated. Then to look into this spot, because 7 has 2 spots for a 2-dimensional space, the second index would be 0. So to access, to put 5 into this spot, you can see that saying our array with the first value, just a new PTR, indicating the random value that you just generated, and then to access that location, which in this case is 7, and then you want to access the value part, that is give you a value of 0. So when that's happening, you can put this equal to element, and therefore you can see that this line is actually what's originally happened over here. That should gives you a very good idea of what's happening. So you need to rewrite the push function by changing the concepts and then doing the whole process over here. So when that is done, you already have 5 stored over here. The next thing that you need to do is that you need to make new PTR next, which is here, equals to top. Originally, top is null in the beginning, so that's totally fine. And you should know how is that going to happen already. So you see that the whole process is actually the same thing over here, new array PTR. And now because we want to look into the next part, so that would be 1 over here, and then equals to top. That's the same thing. The top original is null, so we would, when we see that line happen over here, that null is already over there. So that's what's happening. And finally, top equal to new PTR. So we will be able to generate top originally from null override by the new locations that we put over here. So basically, it's just there. And therefore, that's what I want you guys to do for the operations of the push. And basically, that should gives you a very good understanding of what's happening in our project number 2 for the push function. And of course, you also need to use the same concept to deal with the pop operation as well as the output operation. The output is going to be described over here. So you can see that we discussed about the push function, now top function. This should be super easy if you understand it correctly. Simply do AA with the first index equals to the top, and the second index is going to be 0 because that's the data part of the top item. And basically, I just reveal one function to you already. So just output that value. For the pop, that's something I want you guys to put more thinkings. Make sure it's going to happen based on the concept of the linked list using the 2-dimensional array simulation. For the display, it's going to require you to spend a little bit time on it. Display all the elements in the stack using from top to bottom order. So first of all, top to bottom is a keyword over here. Make sure you understand you want to output all the items from top to the bottom. When you try to output those things, this part give you additional requirements. So don't just output the value because the value is there. I know the value is the value. So not only the value I want you to output, I also want you to output the whole row, including the array index, data value, and the next array index. What I'm trying to say is this. If we output the current situation over here, I don't want you to just output the value of 5. I want you to output the index 7 with some spaces, value of 5 and with some spaces of the -1. So I want you to output the whole row over here. Suppose that we have another push value. So we push another value 32, and then the random index value is 2. So saying that if we push one more item, then what's happening over here is that you're supposed to have this whole thing being pushed over here. The next one is going to indicating where's the next item going to be. The -1 indicating that's the end of the stack. And then you also need to change my top equals to 2. So that should be able to be taken care of by your push function. Saying that I want you to output the display function. what's supposed to output is index 2, 32, 7, and then the next new line would be 7, 5, -1. That is the format of the output I want you guys to do in this project. So saying that you are able to do all the 5 functions, here is the main function supposed to be. After you finish the 6 functions, create an empty stack which capacity equals to 26, and then push 10 values one by one. Push 1, push 2, push 3, push until 10. Of course, every time you push the value, they need to randomly look for a location and then make sure it is available. How do you going to check whether or not a random location is available? There's many different ways of doing that. So I'm not going to limit whatever ways that you choose. Simply make sure the location, that random selection, is available. So when that's happening, you will have 10 elements in your stack. Run display function to print out the whole stack from top to the bottom, and then print it out all the index, data part, next part. Then I want you to perform 3 times of the push of the value 20, 30, and 40 again on valid positions. Run display to print it out the list every time you insert a new element. And then perform 3 times of the top and pop again. Run display to print it out the list every time you delete the item. So, because we are computer scientists, the easier way to describing all those whole long sentences are a main function looks like this. Push 1 until 10 display, and then push 20 display, push 30 display, push 40 display. After that, I want you to run the top function, which is supposed to output what is the top value. Pop, so you pop it away and then run the display again. So for that, you do 3 times of those. And that is going to be your project number 2. What you will need to submit is the output, the screenshot of your output, as well as the source code of your program. Finally, this is your regular project number 2. I do offer you a bonus project opportunity. And guess what? It's about the queue. First of all, I want to talk how good it is for the bonus project. You will get 2 extra points if you get everything correctly on overall score. This is an overall score, so I'll just simply plus 2 in the end of the semester if you get it right. The idea of this one is actually not difficult at all. If you are able to do the stack, Q is a piece of cake. So for Q, I want you basically do the same thing. Use the 2-dimensional space to simulate the whole process. In this process, you would do the construction of 26 locations, 26 and 2, and basically you need to have a from variable and a back variable. So once that is done, you are able to, I want you to use the linked list simulations to do the whole process to create an empty function in Q, from, DQ, and display function. Once all of this is done, I want you to do similar things on the main function described over here. Like I said, if you can do all of this correctly, you will get 2 extra points on overall. What you need to submit is going to be the same thing, screenshot of the result as well as the source code. 2 projects would be described in 2 submissions. So if the project 2 is required by everyone, so all of you need to submit it. If you do bonus project, please, you need to submit the bonus project and project number 2, okay? This bonus is bonus. Now make sure you have the original score as well. And that is going to be the projects I want to describe.